Well, now we come back to France to see what is done on public policy with adaptation to climate change. Something you have to know that 35% of the French coastline is eroding, mainly the sandy beaches. Vulnerability to coastal inundation has been highlighted by the impact of severe storms, mainly on the Atlantic coast, but also on Mediterranean Sea. And the last one is Xynthia in February 2010, where there were 53 persons who died. And the climate change impact will exacerbate existing coastal erosion and inundation hazard, so we have to take into account this climate change. Just a diagram to tell you that political response, there are two kinds of response: mitigation, and but concerning more emission of CO2, and also adaptation. The Ministry of Environment engaged some years ago, since 4 or 5 years, different working group and strategy to manage this climate change, but with and what some instruction where some section of the coastline are vulnerable, whatever the future effect of climate change. It's vulnerable nowadays, and it's going to increase, or new areas are going to be vulnerable. In some regions, we expect an increase of coastal hazard together with an increase of human pressure. The coast is very attractive. In France, there is 2.5 more inhabitants on coastal communes than on the average of France. In this region, it's still possible to choose between an increase of urbanization or to limit this urbanization on seafront. But we have to regulate this. Without any impulse from the national authorities, we expect increase of urbanization in hazardous coastal areas. So we need a national impulse and after work with local authorities. You can see here, there is in Languedoc-Roussillon, south of France, on the Mediterranean coast. This is Mediterranean, the Lido, the highest point, it's 3 meters high, and there are a lot of buildings, and here is the lagoon. I'm going to talk about different policy implementation. We have Grenelle de l'Environnement, with two laws, and then Grenelle de la Mer, which was focused on the ocean and coastal zone. And from this Grenelle de la Mer, there is a stratégie nationale de gestion intégrée du trait de côte in last year with different recommendations and regulations. And in the other way, there is a Plan Climat with different working groups and large dialogue with government, elected representative at regional and local level, the employers, the trade unions, NGO, and experts. So the different groups to explain what happened and what we'll have to do. And at the end, the Plan National d'Adaptation, Changement climatique. And as money, we cannot have too much money, The principle was to use existing instruments and add consideration of climate change, but not create new instruments. So just to explain how it is done, so you have the European level, national, regional level, local level, and it's for cities which have more than 50,000 inhabitants. And it's after in this plan are in local urban regulation documents, which is PLU, Plan Local d'Urbanisme. For it, this organization regional, it's with the préfet de région and the president of under the president of a regional council. So you have the state and the region, and with support with the adaptation, with the analysis of the vulnerability of territories and orientation for adaptation. And it's there is a re-examination every 5 years. So if I come to the Plan National d'Adaptation, there were different groups. I'm going to talk more about this group of erosion and marine submersion. And it's one of the conclusion was to develop observatory networks for long-term series, and to improve the knowledge of natural and anthropic phenomena and their evolution due to climate change. And another important point is the cost-benefit and multi-criteria analysis, what it will be cost and what will be the benefit of an adaptation or a non-adaptation. So, with all this plan, now we need to come back to concrete things, and so which sea level rise scenario we need to take into account for adaptation policies. And so we have the first IPCC, it was between 30 and 60 centimeters. Then we have a lot of publications of papers say it's 1 meter or more, and now it's about 50 centimeter up to 1 meter by the end of the 20th century. So what we have to choose, because the consequences are very important. So and even if science progress, we have to take adaptation right now and have risk prevention decisions. So we make a lot of, we had different group different working groups and different synthesis of the state of the art. And we have a working group to decide what will be what are the official values. It can be changed if the knowledge is changing, and it's by the end of this century it will be the optimistic hypothesis is 40 centimeters, pessimistic 60 centimeters, and extreme 1 meter. But in this working group, there was a lot of discussions, because stakeholders they prefer this one, ministry also, and scientists they prefer more realistic prevision. Now we come on a first sea cable natural risk plan, which is a law in 1995, and this is a opposite document. That means that it's a law and it defines where you can build and where it's impossible to build a new houses. And The recommendation was to do it at the scale of the basin of risk, but in fact it was very often at the communal level. So you can have two plans quite different from two neighbors commune. And the scale of this document, it's 50,000 enlarged to 10,000. And so the first for there were prevention natural risk plan for seism, landslide, but also for littoral risk, coastal risk. So the recommendation were no sea level rise is we don't take into account in the plans, in the maps, the sea level rise, except if technicians decide to take it in account if there are a lot of elements at risk. In fact, it's never taking it into account. Now we are following the Grenelle de la Mer. We have a new PPR, and now the sea level rise is taken into account. It's for a submersion of a centenary return period. You have present hazard, which plus would take plus 20 centimeters to take into account of the present sea level rise. For the hazard by the end of the century, it will be plus 60 centimeters. And there is also a level of uncertainties with models, numerical models, DTM, quality of data, and it's plus 50 centimeters if we cannot know if it is better. So these PPR are on process right now, and there are a lot of discussion with stakeholders and elected members of the communities. And what we found that the inland hydrodynamic flooding models have a better accuracy, some centimeters. I would say we're about 10 centimeters we use, than the DTM, which is a basic data, and the national DTM provided by IGN is the pixel is 50 meter, and the accuracy in height is 1 meter. So for flat area, it's not very accurate. And now we have a LiDAR. Laser elevation model for all flat area, coastal area. And the result we have just the LiDAR for Aquitanian region last March, and it's coming for other region. So, and what I told you that the accuracy of data is very important, because there is a kind, if there is more than 1 meter of inundation, no building is not allowed. So it's important to have precise data. Well, and just it was done already by Sretana this morning about the storm surge. But just to remind you, there is low tide, the tide, which is on the Atlantic coast. We can move. It's very variable. No, c'est ça. There is the atmospheric setup, which is pressure and wind, and then you have the waves, the setup due to the waves. And after the waves, the swash of the waves, there is still power, and they keep going on, and then can make also an inundation. So if the climate change, and there is only 20 centimeters, there will be more inundation, and even the sand dunes will not be enough efficient to contain this storm surge. And we have an example, the Xynthia storm, where the tide was, it was a high coefficient of tide. The storm, the setup was, we have 1 meter and 53 of storm surge of setup, and with a very high, the significant height of the waves were around 7 meters. And so we have a lot of inundation. We have a lot of inundation with in a flat area, even on hinterland with dunes. And an example of plan de prévention des risques, it's in Guadeloupe, in the West Indies. So it's a multi-risk plan. Here there are landslide. In light blue, it's inundation by the river, and also submersion and erosion by the sea. And in red, it's where it's not possible to construct. And as you can see, it's there are some buildings. It's a small square all around. Look here, a lot of houses and buildings are in the non-constructible area. And with this blue dashed line, it's the submersion during the Dean cyclone, which was category 2 of cyclone in 2009. Just to compare, is the PPR was well done of it if it has to be done again. Another example is a marine submersion in the Bassin d'Arcachon. It's on the Acadian coast. This is a Klaus storm with a low, small tide coefficient, but strong wind. And in fact, we have a colleague who has a house just here in Andernos, and there was an inundation in his house. So we can check if our model is well done or not. So, and it was good. We were 10 centimeters. He has 40 centimeters of water in his house. And the year after, there was Xynthia with high tide coefficient, but the wind was less strong. So it's similar. And we asked his colleague. He just repaired his house. He has just finished to repair his house, and again there was an inundation in his house. And after that, we combine strong wind and high coefficient to see what happens. And it's 1.5 meters of height of inundation more. So it's. When you have 40 centimeters, it's not very dangerous, but when we have 2 meters, and it comes very rapidly, it's very dangerous. Now go to the Stratégie nationale gestion du trait de côte. The main point is to create a national network of observation at regional level. And to do it with in relation with regional actors. There are some regional or local networks, but they want to develop this survey. They want also to national mapping of erosion, doing with orthophoto, littoral orthophoto from 2000. And there is a new flight by this time, and they will compare the evolution. And also they want to enlarge the 100 meters public property to take into account the climate change. And they recommend multi-risk PPR and to make defense work at the right scale of the phenomena, I mean the sedimentary cell, and not at the administrative scale, because the erosion or the submersion, it's not. It doesn't stop at the limit of the commune. And also they prepare to recollect to the retreat of limited risk, and with a relocation of activities, and there is a large consultation with local and regional authorities, and now there are five areas where they test the methodology. One is on the Aquitanian region, one on, in Normandy, one in Guadeloupe in the Western Indies, and two in Mediterranean Sea, one in Valras in Languedoc region, and the other in Toulon in the Presqu'île de Gien, where there are a lot of there are different kind of assets, different kind of phenomena. And as an observatory, I'll show you an observatory. It's the Observatoire de la Côte Aquitaine, which is it's more than 16, almost 20 years. And there is a partner with BRGM and ONF, l'Office National des Forêts, which is in charge of the management of forest and littoral dunes in the Aquitanian region. And with the support of the regional government, the region, the state, and the different department, the three different departments, and also community of Pays Basque, which is more cliff, and also the syndicate of stakeholders in the Bassin d'Arcachon. So we have it's in French. A network where we do measurement. We have also a database and GIS, and we are doing a lot of diffusion and communication to public stakeholders and technicians, and make expertise for all these communes. And an example of evolution. Here it's measurement up to 1966, and after this period, as what we can see that the accretion, the erosion is increasing, and so to have some recommendation and make good expertise, it's important to have regular and long-term surveys to manage this coastline where there are a lot of tourists. And an example, the coastline, if there is natural, there is an erosion, the landscape, there is a landward translation of the landscape. But if there are buildings, they want to fix the coast. And there is an interruption in exchange of sediment between dunes, sand beach, and for beach. And so they make a dike very often, so that now we are protected, no problem. But the erosion still continue with the, but on the marine erosion. So nobody knows that, and from time to time, the dike will collapse, and so that it's not also the solution to build on the sand dunes, and it's better to go more on land. Now an example. We were asked in the interministerial working group Risque Naturel Insurance. There were insurance people and changement climatique There were different groups, and I'm going to talk about coastal risk. Here it's in the coastal route in set area on the Mediterranean Sea. You can see that there are a lot of defense work here. And they ask us about adaptation and cost. What will be the cost of sea level rise? So it's a very simple method with a lot of uncertainties, but the demand was to do it with national data. So nowadays, if we have a 10 years return period storm, which is 1 meter of elevation of storm surge, this building A will be inundated. If there is a 100-year return period, it will be this B building will be inundated. If there is 1 meter sea level rise, why we took 1 meter? Because the DTM, the national DTM, the accuracy is 1 meter in height. So it's we couldn't do something better. So that means that with 1 meter sea level rise, there will be permanent inundation. The one we were just inundated with 100-year return storm, it will be each 10 return period, and the sea buildings which were safe will be inundated. And I want to show you, so it's in Languedoc area, the methodology, we did this study in Languedoc area, and what we can see, it's with 1 meter sea level rise, you can see that the Lido will be inundated, there will be permanent inundation. Because there are communication between the Mediterranean Sea and the lagoon. So there will be attacked by the sea and front line, but also backward. So as you see, and there are a lot of buildings. And after that, we came to see what is the land use in this area. What you can see here, it's from the sea and to inland. And there in red, it's the urban zones. And what you can see is that there are a lot of urbanization in the first 500 meters, and it's decreasing. Everybody wants to come on the front line. And we in this, so with this scheme I show you, there are irreversible and permanent inundation or erosion hazard. The population, 80,000 people will be touched by that, and 140 residencies. There are more residencies because it's holiday residencies, and we just take into account permanent inhabitants. Not because it's a choose, and in 2000 it will be there will be also temporary inundation, more people, and we try to have an evaluation of the cost of the damage. And it's between, but it's very, very rough. But we try to do it, and it will be 15 to 35 billion euro for the century. But with lots of uncertainties. Just to show you, it's the IGN, the national DTM, and this is the LiDAR DTM, which is more precise. So, and the recommendation that we have done, it's to There are different strategies of adaptation, of managing the coastline. They do nothing, because a lot of representatives, they say, well, as scientists, they doesn't know very well what is going. We do nothing. But what we say is doing nothing. It's a strategy. So you have to choose between different. So relocation, hold the line if the element at risk are important, or to have a limited intervention, for example, in wetland, to manage the sea level rise. So I'm going to the last, because so adaptation recommendation are, it's always the same. It's to enhance knowledge, have regular data collection, to the need of accurate DTM, which is the basic data to propagate inundation. And also, if there is a gap, and they need to have more communication between scientists, public, and stakeholders, and they don't understand the scientific papers, so have to have a communication to, I would say, translate scientific papers in something comprehensible for public. Development of planning program that take into account climate change. Now it's on process. That the study and the protection of the coastline have to be done at the right level, not at administrative level, but at the basin of risk. That we have also a panel of different type of defense works, and not only dikes. We can be used and adapted to each case. And also now we are going to also prepare relocation of element at risk, which cannot be protected. And also, very important, it's the insufficient data for robust cost-benefit analysis. And also a recommendation is also to adopt without regret solution, because we have to do it with or without sea level rise. And we have to pay attention that if we over-adapt, there will be a high cost of adaptation that government will not do. And if there is an under-adaptation, there will be a high cost of damage. So we have to be in between these two solutions. Thank you.